Hi everyone, this is Mr. Richmond, and for this video we're going to have a look at some examples on how to count the amount of atoms in some various chemical formulas. So before we do that, let's go back and review some of our vocab terms so you can follow along. So the first term that we're going to talk about is an element. The important thing about an element is that it is a pure substance, meaning that it cannot be broken down by a physical change. In order for us to change its composition, it has to undergo a chemical change. Its most basic unit is going to be the atom, and each atom that makes up an element is identical to one another. So that's a very important concept about our understanding of what an element is. Every single atom is identical. So when we have two or more different types of atoms or two or more different types of elements combined or chemically bond together, we refer to that as a compound, and its smallest unit of matter for a compound is a molecule. An example would be H2O. Everyone knows that is water. 2 hydrogen atoms for every 1 oxygen atom. This is also considered to be 1 molecule of water, and we're going to get into some examples of some chemical formulas that might help you get a clearer understanding for the difference between a molecule and a compound. So let's have a look at our assignment, how to count atoms. So a few different things that we want to know here. First of which is identifying an element symbol. You don't need to know what Ba is. However, you do want to know that every time that you see a capital letter in a chemical formula, you should know that we are looking at a different element. So we're going to get to this in a second, but as you can see, I have got a capital C, capital P, capital O. So even if I don't know that this is calcium, phosphorus, and oxygen, I should be able to identify that there are 3 different elements that are chemically bonded together in this chemical formula. So let's backtrack to our first example. How many atoms of Ba do I have? Well, I don't see a subscript, which identifies how many atoms that we have in that element. I don't see a coefficient, which tells us how many molecules a coefficient is in front of the number, or in front of the element symbol, or in front of the chemical formula. So if I don't see a coefficient, I don't see a subscript, I'm going to assume that there is 1 atom of barium here, Ba. The next one, I do have a subscript. That is the number that is in the lower right-hand corner of an element. And this tells us how many atoms of Cl do I have. So that would be chlorine. So it tells me that I have 2 atoms of chlorine. Now we're going to get into some more complicated ones. You've got subscripts that can be outside of brackets. So the first element that I see here, Ca, which is calcium. This subscript, 3, tells me that I have 3 atoms of calcium. So here's where it gets a little bit complicated. This subscript applies to everything on the inside of these parentheses or inside these brackets. So I need to distribute this 2 to both this P, phosphorus, and this O, oxygen. So I'm going to use this as a multiplier to whatever is on the inside of these parentheses. So 2 times 1, if I don't see a subscript like I did for here, barium, I'm assuming that there's going to be 1 atom. So 2 times 1 atoms of phosphorus, that would be 2. 2 times 4 atoms of oxygen, that's going to be 8. So you can see what I did here. I just distributed and used this as a multiplier to everything on the inside of those parentheses. Alright, so let's get to a couple examples of ones that have a coefficient. Let's start off pretty easy. I see I have an element symbol of C, that's carbon. I have a coefficient of 3. Just like with this little subscript, you're going to distribute or apply that coefficient throughout the entire chemical formula. So whatever's in front of this coefficient, I'm going to use as a multiplier. So 3 times, I don't see a subscript, so I'm going to assume that that is 1 atom. 3 times 1 is 3 atoms of carbon. Now for this chemical formula, I've got NaSO. I see 3 different capital letters, so that must mean that I have 3 different elements of Na, that's sodium, S is sulfur, and O is oxygen. So remember, I need to use my coefficient to use as a multiplier throughout the entire chemical formula. So 2 times 1 of sodium, or Na, that's 2. 2 times 1 of sulfur, that's 2 for sulfur. Then 2 times 4 of oxygen, and that is 8 for oxygen. So let's do one more that's a little bit more complicated when we combine both the parentheses and the coefficient, and that'll be the last example I do off this worksheet. So I've got a coefficient, I've got parentheses, there's a lot going on here. I've got a subscript outside the parentheses as well, so this one's about as complicated as it gets. So if you recall what I was discussing a little bit earlier in the video was that this coefficient, this number in front of our chemical formula, tells us how many molecules of this chemical, of this compound that we have. So how many molecules do I have? I've got 4 of this PbNO32. How many atoms of Pb or lead do I have? Well, I'm going to distribute that 4 throughout the entire compound, so 4 times 1 is 4 of lead. Of oxygen, oxygen's a little bit tricky. I'm going to distribute this 2 to the inside of both of these elements. It looks like we forgot a space for nitrogen, so I'm going to put nitrogen down here. I'll come back to that in just a second. So for oxygen, I'm going to distribute this 2 times 3, that's 6, times 4. So that's important. Do not forget about this coefficient. So just like I did with my previous example, with the parentheses up here with Ca3PO42, I want to distribute this 2 to the oxygen and the N. So for oxygen, it'd be 2 times 3 is 6, times 4, 6 times 4 is 24 atoms of oxygen. Then finally, I'm sorry, I'm working a little bit backwards here. Now I'm going to go to N, or nitrogen. That will be 2 times 1 to nitrogen. 2 times 4 is going to be 8 atoms of nitrogen. So again, you want to make sure that you distribute this 2 to both these capital letters, both these different types of elements. I hope this helps your understanding with counting atoms for different chemical formulas, and good luck.